If I take a look at the data center network evolution, we have different things that we've started with over the years and have built to newer technologies to get to these new emerging things. So historically, we've started with spanning tree 802.1d based designs. It worked. We've had it together for years, and many customers still have these things deployed, meaning it's classical spanning tree. The amount of links I throw at the network, so if I scaled those two top boxes here on a horizontal fashion, I'm going to block every single link because I'm going to forward on my spanning tree root port. Let's just say this is spanning tree root. He's going to go ahead and forward, and all the subsequent links will be blocking until there's a failure within the network. So then we've evolved to VPC-based tiering. VPC still relies on spanning tree from an insurance factor, from a loop avoidance perspective, but from a data plane forwarding point of view, we're still active-active, and I'm forwarding on two given interfaces. Also, from an L2, L3 boundary perspective with VPC, typically what I have is my L2, L3 boundary sitting here, and my default gateway from a server is here. So it's active-active both from a layer 2 data plane and also from a downstream server point of view. The default gateway is going to live here. The HSRP is active-active here. With VPC, I cannot scale beyond 2 nodes. So I'm limited to 2 nodes. How we scale the 2 nodes is we've developed Fabric Path. Fabric Path does not rely on spanning tree. If I connect spanning tree domains to this Fabric Path network, think of all of these devices as one logical root bridge for all the downstream facing spanning tree. We do not send spanning tree across the Fabric Path domain. I can also take the same account. I can scale to 4 devices leveraging Fabric Path by leveraging Anycast HSRP. To where the maximum I can do is 4. That'll give me 4 devices for my downstream servers to have a default gateway, and I can scale the east-west with the VLAN Anywhere concept. The other advantage is it reduces the VPC state between the spines. It is no longer needed to get Anycast HSRP between the spine devices. Cisco's software-defined networking strategy, or SDN, in providing choice for customers in automation and programmability. On the first pillar, we have application-centric infrastructure. Application-centric infrastructure defines policy on a per application or tenant basis. It also provides underlay and overlay automation and provisioning, as well as services integration in an automated fashion. The second one, which is the primary focus of this lesson, is Programmable Fabric. Programmable Fabric is a standards-based VXLAN, BGP, EVPN address family, and this is going to be the main focus of the live lesson. It also has a controller which will provision the overlay infrastructure for Programmable Fabric. The last pillar is Programmable Network. Programmable Network allows for to integrate your traditional Nexus 9K through 2K infrastructure with an open NX API to allow automation and provisioning from things such as Puppet and Chef, which are agent-based, or Ansible, which is agent-list-based, across the data center network.